This video going to show what is hopefully something that most of you can see already. It's a pretty straightforward proof. And if you like seeing straightforward proofs, subscribe to my channel. So they are telling you that these n numbers, a1, a2 up to a sub n, is a complete set of residuals modular n. And we have that the GCD of a and n is 1. Okay, so what can you tell me about a1, a2? So let me say consider that all the way up to a times a sub n. Okay. Now, these are clearly different values. So, yeah, they're n numbers. They're n numbers. What I want to show is that, well, yeah, they are different values, because if a1, a2 up to an are different, well, then multiplying it by a non-zero number a will do the same. They're different. But that's neither here nor there. We have n numbers, and I want to show that these numbers modulo n are all different. Okay. So consider a times a sub I congruent to a times a sub j mod n. Okay, I is not equal to j. In fact, let's say one is bigger than the other. Say I is greater than j, and to really state it, not equal to. Okay, so I is bigger than j. Well, this tells me that a times a sub I minus a times a sub j is a multiple of n. It's k times n. Okay, so let's get rid of that. In fact, let's just say I and j are different. Proof's a lot simpler than I thought. I and j are different. Now, there's a rule that says that I could divide everything by a. I can divide by a, I can divide by a, and I meant to say over here, I have to divide by the GCD of a and n. That's the theorem. So we have that ai is congruent to aj mod n over, look at that, the GCD of a and n is 1. That is, a sub I is congruent to a sub j mod n. That is, these two are different as long as I and j are not the same. Because this first line is if and only if the second line, all I did was divide by a, and I have to play games with the mod. But that's if and only if ai equals aj, but this is not true. Well, I should say that since these are complete, or they come from a complete set of residues modulo n, this implies that I equals j. That is, these were the same. The only way they're congruent as if they're the same. And I did it in general. All of these give different, they're different in mod n. Okay, so using their language they did, we now have a complete set of residues mod n. So A1, A2, all the way up to AN is a complete set of residues. Complete set of residues mod n. Modulo n. And that completes this proof. As always, if you like seeing mathematical proofs, this is a website to come to. No matter which video you click on, you're going to get to see a mathematical proof. See you guys in the next video. Don't forget to watch my videos and learn.